Hello everyone. Thank you for coming to another Open Cluster community meeting. Today we're really excited to have Liang to present the placement rule API enhancement. So without further delay, Liang, you can share your screen and please take it away. Thank you.
Okay, thanks, Mike. Let me share my screen first. Could you please stop sharing your screen? Then I can. Oh, thanks. Okay, hello, everyone. This is Le Yang. Today I will update the current status of placement APIs and the roadmap. As we already know, OSM have placement APIs. User can use it to select manage clusters from one or multiple cluster sites. Now we have several draft enhancement proposal for placement APIs. I think the link for those proposals has been posted in the community Slack channel. The first proposal is created by Chang Xu. It's about toleration and attempt and toleration. The motivation of this proposal is to support filtering unhealthy and not reporting clusters. The second proposal is for a placement scheduling based on cluster capacity and resource usage. Today I will walk through this proposal later. And another proposal is about supporting select global scoped clusters. So we are very, I think a lot of people have already provided their comments for those proposals. I think they are still under review, and further comments and suggestions are welcome. Today I will I'd like to walk through this proposal. The placement scheduling based on cluster resource usage. Besides Google Doc, we also create a PR in the enhancement repo. Let me open this PR. Here is a proposal for this feature. So in this proposal, we are going to extend the placement APIs to support placement scheduling based on the resource usage and capacity of managed cluster. The motivation is we'd like to avoid to schedule a workload on managed clusters which has no desired resource. We have collected several user stories for these features. The first one is user can create a placement and specify resources to select managed clusters whose allocatable to capacity ratio is larger than others. The user story 2 is user is able to create a placement and specify the resource to select clusters with more allocatable specific resources. The difference between user story 1 and user story 2 is one is sort the cluster by allocatable to capacity ratio, and the other is allocatable resource. User story 3. Once a placement select cluster based on resource usage, the scheduler will keep the placement decision updated according to the usage changes. That means the placement decision will be updated in time once the resource usage is changed on the select managed cluster. The story 4. The placement select cluster based on resource usage at the initial placement scheduling. After then, it will ignore the usage changes and keep pinned the cluster decisions. So in this user story, the resource usage or capacity data will only be used at the initial scheduling. The last user story is support scheduling based on usage and allocatable of resource other than CPU and memory. For example, we may need to support scheduling placement based on GPU usage or even the network bandwidth. Actually, in this proposal, we only want to cover user story 1 and 2. Because user story 3 and 4 are related to churning policy of placement. And this two user story, I think, is better to be covered in a separate enhancement proposal. It's very complicated, actually. And the user story 5 support other kind of resource. We will not support it too until we got a very clear requirement. Let's go to the proposal details. So in this proposal, we are going to add a field, cluster resource preference, into the spec of placement. In the cluster resource preference structure, user is able to specify the preference type. It has two values. One is the most allocatable to capacity ratio. The other is the most allocatable. And user can also specify the resource names. At least one resource name should be specified in the cluster resource array. Now we only support the CPU and memory as a resource name. If we need to support other kind of resource type, we need to extend this API. Besides the API change, we also need to create two prioritizers for those two cluster resource preference types, respectively. Here there are two examples. The first example is a placement. It will select 3 clusters whose CPU and memory usage is less than others. And we can say we can specify cluster resource preference with two cluster resource. One is CPU and the other is memory. We didn't specify the cluster resource preference type here. It will use the default value, most allocatable to capacity ratio. If we specify more than one resource here, each resource will share the same. Each resource will have the same weight when the prioritizer try to score the feasible managed cluster. The second example, we have a placement. It will select a cluster with the largest memory available. In this placement, we have a cluster resource preference. Here we specify the type. The value is most allocatable, and the cluster resource is memory. Let's dive into more details about this proposal. To support the user story 1 and user story 2, we need two kinds of resource usage data. One is allocatable, the other is capacity. They are all class level data. That means, for example, the allocatable is the sum of the allocatable on each node in a managed cluster. Now all those data are available in the status of managed cluster. As we can see, if we want to support other resources like GPU, we need to put their allocatable and capacity data in the status of managed cluster as well. And now let's say some details about the most allocatable to capacity ratio plugin. This plugin actually is a prioritizer, and it will score each feasible managed clusters. I list the process here. If the cluster resource preference type is specified, and the value is most allocatable to capacity ratio, so we will have a formula to calculate the score of a managed cluster. It will sum the allocatable to capacity ratio on each resource. And then before we return to if we don't have a cluster resource preference specified, or its type is not most allocatable to capacity ratio, this plugin will return 0 as a score for each managed cluster. Before we return the score, for each cluster, we will have to normalize those data into a fixed range. Here, the range for this plugin is the value will fall into the range between 0 and 100. For another plugin, most allocatable, it's also a prioritizer. And it has a similar process when score a feasible managed cluster. The difference is the formula to calculate the score. For this plugin, because we will compare different resource type, so we need to normalize the allocatable of different resource into a fixed range. For example, 1 to 100, 0 to 1 first with this formula, and then summarize us when add them together to get the score. So before return the score to the scheduler, the score value should be normalized as well. Now let's see how those two plugins will work together with the existing plugins, especially the prioritizers. As you may already know, the scheduler for the placement has a plugin framework. There are two kinds of plugins. One is a filter. It will filter many cluster with some match requirements. Another type of the plugin is prioritizer. It will score each feasible managed cluster, return a score for each one, and then we can sort the managed cluster with the score. Now we have two existing prioritizers. The first one is the balance prioritizer. This plugin will balance the number of decisions among the clusters. So the cluster with the highest number of decisions will be given the lowest score, while the empty cluster will give the highest score. This plugin is used to balance workload between across the managed clusters. Another prioritizer is the steady. This plugin ensures the existing decision is stabilized. So if a placement has already selected a cluster, so in the next scheduling cycle, the placement will favor these selected clusters. That means that cluster will have a higher score value than others. So the final score of a managed cluster actually is the sum of all the score from all the prioritizers with equal weights. So with these two new introduced prioritizers, we have 4 prioritizers in the plugin framework. That also means the placement decision cannot be decided by a single prioritizer. Here is an example about this. So we suppose the class resource preference is specified and the type is most allocatable to capacity ratio. So in that case, the most allocatable plugin will always return 0 as a score for each cluster. And we have the data. The table here will show all the score from each prioritizers. As we can say, the cluster 1 will beat cluster 2 and cluster 3 because the total the total score is larger than others. But actually, its score from most allocatable to capacity ratio plugin is is small than cluster 2. Even we have this cluster resource preference specified in a placement. So I think that's pretty much about for this proposal. If anyone have any questions.
Hey, Lei Yang. This is Michaela here.
Sorry, no questions so far. Leanne, do you still need to continue?
No, I don't think so.
Hey, can you all hear me?
Yeah.
Okay, yeah, Michaela here. So thanks, Lei Yang. I don't have any questions, but thank you so much for sharing the placement API enhancements today. And Mike is having some background noise issues. So if there are no other questions, I propose that we go ahead and conclude this meeting. Last go round, any other questions for anyone? No? All right then. Well, thanks, Lei Yang. Everyone have a great day and looking forward to seeing this all come to life.